Chapter 3, Section 1 is about lines, angles, and slopes. And we start with definitions of 4 different types of lines. Parallel lines never intersect and have the same slope. And this is our symbol for parallel, and those lines are in fact parallel. Over here in this picture, this little arrow right here, those mean that the lines are parallel. So we can say line AB is parallel to line EF. Perpendicular lines meet at a 90-degree angle or a right angle, and their slopes are opposite reciprocals. This upside down T is the symbol for perpendicular. And I am going to say EG is perpendicular to GH. Intersecting lines cross at one point, and there's no relationship at all between intersecting lines. And let's say EF and FH are intersecting. That just means they cross. And skew lines are not parallel, they do not intersect, and they are not coplanar. And for skew lines are like this. My fingers here are skew. They're not parallel, but they don't intersect. And for skew lines, I'm going to say line EF and line BD. So EF right here and BD are skew. And the first thing we're asked to do with examples is just identify each of the following. Parallel lines. Boy, it's kind of hard to read here, isn't it? This line right here is NS, and that is parallel right here to line MR. Skew segments, I'm going to use NS again, and NS is skew with ML, and I guess we wanted segments. So I'm going to put the segment symbol above that. Perpendicular segments meet at a right angle. So I am going to use MR and RQ. And then parallel planes, I'm going to use the top and the bottom. So we will call this plane LMN and plane SPQ. Example 2, parallel segments would be right here. I'm going to say BE and FJ, and I put the segment symbol above it. Skew segments, I'm going to say BE and JH. Right here is my perpendicular symbol. So our perpendicular segments are FB and FJ. And there's more than just that. That happens to be the one I picked. And parallel planes, I'm gonna do plane BCD, which is the top, and plane FGH, which is the bottom. Slope of a line. Slope is how steep a line is. The rise is the difference in the y values of the 2 points, and the run is the difference in the x values of the 2 points. The slope of a line is the ratio of the rise to run. And if these are points, x1, y1, x2, y2, then your slope is y2 minus y1, x2 over x1. And sometimes I think all these little subscripts get confusing. So sometimes I just write y minus y over x minus x. And also, rather than saying rise over run, I like to say rise over right. And that helps you when you're graphing. How much you go up or down, and then how much you go to the right. So our next example, we are asked to use the slope formula to determine the slope of each line. And I'm going to write that formula here just so I have it to refer to. And I'm going to start with CD. I'm going to start with the last one. D is the point, -2, 1. And C is the point, 4, 2. So from C to D, to find our slope, we do y minus y over x minus x. Doesn't matter which one we start with, as long as we start with the same x and the same y. So I'm going to do 2 minus 1 over 4 minus a -2. When you subtract a negative, you zip-zap that, and you end up with 1/6. Or we go up 1 and 6 to the right. I'm going to do letter B next, which is AC. And that point is -2, 7. So to find the slope from A to C, I am going to do 7 minus 2 over -2 minus 4. And that becomes 5 over -6. Which is a -5/6. So that means you go down 5 and 6 to the right. And 5 over -6 is the same thing as -5 over 6. And it doesn't matter which way you write that, whether it's 5 over -6 or -5 over 6. Next I'm going to do AD. We have the point -2, 7 and -2, 1. So y minus y over -x minus x. That becomes 7 minus 1 over -2, subtract a -2. So this becomes 6 over 0. And if you divide by 0, that is undefined. And you can say undefined slope or no slope, but for that line, you cannot say a slope of 0. AB, we have the point -2, 7, and B is the point 3, 7. And when you do y minus y over x minus x, you end up with 0 over -5, which is 0. And that leads us to our 4 types of slope. If your line goes up, that is positive slope. If your line goes down, that is negative slope. If your line goes straight across, that is a slope of 0. And if your line goes straight up and down, that is undefined. So positive slope, negative slope, zero slope, and undefined slope. So our next example, we are asked to find the slope and see what it means. So for slope, I am going to do 330 over 180, and then over 5.5 minus 3. And that becomes 150 over 2.5. And if we divide that, we get 60. Well, we were also asked to explain what that means. Does that mean 60 students per class, $60 per hour, 60 pounds per box? And if we look here, the Y's are on the top, so it's distance in miles over time, which is hours. So that means we go 60 miles in 1 hour. Before example 5, I want to just write a reminder here. If your lines are parallel, that means they have the same slope. And if your lines are perpendicular, that means the slopes are negative reciprocals or opposite reciprocals. Negative reciprocals. And I'm going to list a couple of negative reciprocals, like 2/3 and -3/2, 1/4 and -4, or a special case, 0 and undefined. Perpendicular lines, your slopes are negative or opposite reciprocals. So finding the slope right here for UV, y minus y over x minus x, y minus y, x minus x, and that becomes 3 over 1, which is 3. The second line, xy, I am going to do y minus y over x minus x. 1 plus a -3 is a -2. 3 plus 3 is 6. And that reduces to a -1/3. Those slopes are opposite reciprocals, so the lines are perpendicular. Letter B, finding the slope of GH, y minus y over x minus x. That becomes a -4 over -4, which is 1. The second line, IJ, y minus y, about 4 minus -4, and then -2 minus 2. That becomes 8 over -4, which is -2. And if you look at the relationship here, they have nothing in common. So those lines intersect. And the last one, CD, -3 minus 1 and -1 minus 1. I'm going to zip zap both of those. And you get -4 over -2, which is 2. And line EF, 1 minus 3 over -1 minus 0. And that becomes a -2 over a -1, which is 2. So those have the same slope, so those lines are parallel.